Hello everyone. In a previous video, we saw the mechanism of calculating the expected return and portfolio variance for a two-asset portfolio. In this video, we are going to work in Excel to calculate the expected return and the variance of the portfolio. For that purpose, we have some information here. We have two assets, asset 1 here, asset 2 here. Their percentage return is given to us in this column, and their standard deviation is also given to us in this column. We have also been provided with an estimate of the covariance between these two assets, which is 72 here. Let us say that we want to invest 40% of our money in asset 1 and the remaining 60% in asset 2, so that the weights are 0.4 and 0.6 on asset 1 and 2 respectively. Let us find out the expected return in this cell, and in this cell we are going to use matrices to find out the same expected return. Expected return is equal to W1, which is this, multiplied by the return on the first asset, which is this, plus we need to have W2, which is this, multiplied by the return on the second asset, which is this. Hit enter and you should see the expected return of 6% on display. We can also do the same thing using matrices. We need to multiply two matrices. One matrix is going to be the transpose of the weight vector, and the other matrix is going to be the return vector. So let us do that. We invoke the mmult function. The first array is going to be the transpose of the weight vector. So let us write transpose and provide the array for the transpose. This is that array. Close brackets, comma, and then we need to provide the second array for matrix multiplication, which is the return vector, which is this. Close brackets and hit Control, Shift and Enter all at the same time. So we have the expected return of 6% here as well, using matrix multiplication. Now let us move over to finding the portfolio variance. We are going to first of all use the bordered variance covariance matrix. On the border here, we want the first weight to appear. So we are going to write the same value as cell D2. This is the first weight. And in this cell, we want to write the weight for the second asset, which is in cell D3. So we are going to write D3. We have done the same thing on this side as well, D2 and D3. In this space here, we are going to write our variance covariance matrix, which we named S in a previous video. So let us write down the variance covariance matrix. You will recall that on the diagonal appear the variances. So in cell 1-1 here, we need to write the variance of the first asset. Here is the standard deviation of the first asset. So what we need to do, we need to square the standard deviation to get the variance. So we can say the square of this cell. In this cell, we need to write the covariance between asset 1 and 2, which is given to us, 72. So we write that here. In this cell, we again have to write the covariance between assets 2 and 1, which is the same thing as covariance between 1 and 2. So we write the same value, 72. On this diagonal element, we need to write the variance of asset 2. This is the standard deviation of asset 2. So we select this and square it up. So this is the variance now of asset 2, which completes our bordered variance covariance matrix. This is a border and this is the other part of the border, and inside the two borders is the variance covariance matrix. Now excuse me, now we need to find the variance. How do we do it? We need to multiply, first of all, this cell with this cell and this cell, and then we need to multiply this cell with this cell and this cell. Let us complete this operation. For the second operation, we will need to multiply this cell with this cell and this cell, and also this cell with this cell and this cell. You will notice that in these multiplications, this part will remain the same. So we don't want to change it. Let us see how we are going to go about it. Let us deal with this part first. We write an equality sign. We need to multiply this value here, which occurs in cell B9. So we will write B9, and we are going to multiply it with this, and then again this has to be multiplied with this and this, so we can use the sum product function. Let us do that. Sum product. Let us provide the arrays. This array is the first array and this array is the second array. We can now close the brackets. This is the value that is returned, 40.32. We need to do the same thing here, but we also need to keep cells A10 and A11 unchanged. We can write a dollar sign to keep the cells unchanged. We don't want A10 to change. We also don't want A11 to change. So we can write the dollar signs to tell Excel that this range should remain the same. And then we can just drag this formula towards the right. We are going to get this result, 161.28. We know from a previous video that the variance is going to be the sum of this value and this value. So instead of writing variance here, I can write variance here and calculate the sum of these two values. I can say sum and provide my numbers. This is the variance, 201.6. We can also find the variance using matrices. But this time it's going to be a product of three matrices. If you will recall, if we need to use matrices to find portfolio variance, we need to multiply W transpose with the variance covariance matrix, and this product needs to be multiplied with the weight vector again. So we are going to have to use the mmult function twice. Let us do it. mmult. Inside we are going to write the first product, the product between the transpose of W and the variance covariance matrix. So let's write mmult again, transpose of the weight vector, which is this, close brackets, provide the second array for the inner matrix multiplication, which is going to be the variance covariance matrix, which is here. Now we need to provide the third array for matrix multiplication, which is going to be the weight vector again. This is the weight vector. We close the brackets and hit Ctrl, Shift and Enter all at the same time. And we see the same value again, 201.6. That is the variance of this portfolio. This is all I wanted to tell you in this video. See you later.